So this is 3/20/15. We are going over the percent yield quiz. So this can be treated as a tutorial later. On your first problem, a reaction between iron 3 oxide and sodium nitrate runs with sufficient reagents to produce 39.40 grams of iron 3 nitrate. Yet when the reaction is complete, the mass of iron 3 nitrate that is measured is 387.2 grams. What's the percent yield? So you have to unpack that a little bit. This is the simplest type. This is where I give you the theoretical, I give you the actual, all you have to do is the percentage problem. And this is the one that a lot of people did well on because they realized, oh, this is the easy kind. So you don't even have to write the reaction for this unless you need to do that to make sure that you clarify which are your reactants and which are your products. If you need to do that, it looks like this. So you could do that, you could balance it, but I'm not even going to balance it. It's a lot of work here, and you don't need to do any of that. But if you write a formula equation for this, you go, oh, okay, well, these are my reactants, and the product that I'm interested in is that. You're not given any mass of your reactants. All you're given is a mass that you should be able to produce of your product and a mass that you do. So all you need to do is actual over theoretical times 100 with the numbers you're given. That looks like this. We have that, and then when we put in a raw number, we get 96.94541, etc., etc. It just goes on. We have 4 sig figs to work with. So this ends up as 96.95% yield. Okay, so it's the easy one. You didn't even have to write that formula. It's totally unnecessary. A few people, I think, got themselves wrapped around the axle and tried to do stoichiometry here. There's no stoichiometry to do here. This is the simplest case. Now let's look at the next one, which is the medium difficult. So you were given the equation. You didn't have to write that. And you were told that you get 325 grams of lithium hydroxide, and you produce 462.4 grams of iron 3 hydroxide. So what we want to know is your percent yield. You don't have to find a limiting, okay? You're just being given an amount of one reactant. You do a simple stoichiometry over to find your theoretical. So you would start with this given reactant and go to this to see how much you should be able to produce. Your factor label will look like this. So this takes you from the mass of lithium hydroxide that you were given to the mass of iron 3 hydroxide that you can create. And the raw number we get for that is 483.4516. It goes on and on and on. Grams of iron 3 hydroxide. So now you've got a number that you can plug into your calculations for percent yield. So we've got our actual over theoretical times 100. Your actual was given in the problem. Your theoretical you just computed. We get 95.64, etc. We only have 3 sig figs here. Why? We have to go back to that. That's the first number that we were given that starts our calculations. So it's tempting to look at this and go, oh, I've got 4 sig figs. But if you go all the way back to the beginning of the calculations you did for this problem, that governs your sig figs. So with 3, we get 95.6% is our yield. Okay, those are the medium hard ones. How do you know if you don't need to find a limiting and an excess? If you're only given a mass for one reactant, you're just going through to theoretical. You're just taking that mass of a reactant, in this case it was lithium hydroxide, and doing a factor label through to find a theoretical yield of one of your products. If you're given masses for 2 reactants, you have to figure out which one is going to govern how much stuff you can make. Questions on this one? Okay, so hearing no questions, that idea of figuring out which of your reactants governs how much you can make leads us right into question 3. So of course for question 3, you're not even given a reaction, so you have, or an equation, so you have to write the equation first. You're told that magnesium oxide reacts with aluminum to form aluminum oxide and magnesium metal. So Mg and Al2O3. When you balance that, it looks like that. So now you've got a balanced chemical reaction to work with. You're given 265 grams of aluminum. You're given 315 grams of magnesium. I do that for myself. I jot the amounts I've been given underneath them because it's less likely that I'll sort of lose the numbers or cross them or, you know, screw up and think I have 315 of the aluminum and 265 of the magnesium oxide. So that's just my little bookkeeping thing. You don't have to do it. And we're told that we produce 235.5 grams of the aluminum oxide. So we want to know what the percent yield is. Well, we have to know which of these things we're going to use all of. Which is our limiting? Which will we run out of? And to do that, you know, you can go either direction. I started off with 265 aluminum, and right now all I'm doing is comparing my two reactants so that I can see which one is my limiting. Okay, so I have a factor label that's comparing my two reactants. I'm going to see what I get here. I get a raw number of 593.8926, etc. grams of magnesium oxide. So, if I wrote my sentence, 265 grams of aluminum could react 593.8, etc. grams of magnesium oxide, but we have, and we could insert the word only, 315 grams of magnesium oxide, so we run out of magnesium oxide. I would have written that, but I ran out of room. Okay, so I now know that magnesium oxide is my limiting reactant. The amount of magnesium oxide I have is what's going to control how much product I can make. So now I start another factor label. I'm going to clear a few things. Okay, so I'm starting a factor label with the given amount of my limiting reactant, which is 315 grams of magnesium oxide, and I'm going to take this over to a mass of the product that I'm interested in. So I want to find the theoretical yield of aluminum oxide. Okay, so I now have a factor label that takes me from an amount of my limiting to a mass of my limiting to a mass of the product that I'm interested in. The raw answer that I get here is 265.586, etc. grams of aluminum oxide. Now I'm ready to do actual over theoretical equals times 100 equals percent yield. Okay, so I get a raw answer of 88.6716, etc. It keeps going. When I take that to 3 sig figs, which is what I can have because of this 315, it ends up as 88.7% yield. That's pretty low. That's pretty low even in here. In a high school chem lab, you should be able to achieve, and most of you can, 90 or above. When you get up into 98, 99, that's where I go, wow, you're pretty special. You're pretty good. 88, I would be saying, you need to write me an explanation of what the heck happened here. And that kind of percent yield is usually, we spilled our stuff. Oops. So, okay, questions, comments, or concerns? That is percent yield. You've got homework to practice on this with. Monday we'll be talking about the SOAP lab and the SOAP lab pre-calculations and working on that stuff. Tuesday I plan to have us making soap. So that's the goal.